Hey, let's try doing this problem. We have a double integral of 5y squared dA, and your region is some triangular region that has these points as 0, 1, at 1, 2, and at 4, 1. So we can draw a triangle out of that. And we see our little region over here. Now, what we're interested in is trying to figure out what to integrate with respect to first. And if we integrate with respect to y, we can see that as long as we make these cuts, we're going to go in through one region and we're going to exit another region, but that only goes from x goes from 0 to 1. After that, we're going to change functions. So doing it this way would require two integrals. And we want to simplify our work as much as possible. So now instead of integrating with respect to y first, what if we integrated with respect to x first? If we integrated with respect to x first, we will enter through one function and exit through one other function from start to finish. So that looks good for us. I think we're going to want to integrate with respect to x first. So we're going to set up our limits for integration. And I said we're going to integrate with respect to x first. So let's put x here. And then y will be constants. Well, I can see my y values already. Y goes from 1 to 2. And I know that these are constants because that's our rule, that the outer limits must be constants. So now I need to figure out what the x functions are. Let's see, we're going to enter through this function over here. I can just immediately see that the y-intercept is 1. And the slope looks like it's also equal to 1. And so we got y equals 1x plus b, which is 1. And unfortunately, I want to solve for x here, and it's not x. So that's just a simple equation that we're going to solve for x. So we'll bring the 1 over to the other side. We get y minus 1. So that's going to be my lower limit function. My upper limit function is going to might require a little bit more work, and I have a slope, so my rise over run, the difference in the y's 2 minus 1, the difference in the x's 1 minus 4, so it looks like it's going to be positive 1 over negative 3, so my slope is going to be negative 1/3. And I can try to anticipate what my y-intercept is, or I can just use one of these points. So let's use y minus y1 is equal to the slope times x minus x1. And then if I just solve for, I want to solve for x, so why bother solving for y here? Let's just go ahead and solve for x because that's what we want. We'll bring this over to the other side. This would be negative 3 y, and then negative 3, negative 2 is positive 6 is equal to x minus 1, and so we subtract, we add 1 to both sides, so x is going to be equal to minus 3y plus 7. So that looks like it's going to be my function on the upper part, minus 3y plus 7. So that's it. I'm ready to set up my integral. My integral then would be a double integral. My inner integral, well, my integrand is 5y squared with respect to x first, dx, and my x limits go from y minus 1 to minus 3y plus 7, and my y limits go from 1 to 2. So this is my integrand. We can easily solve for that. There's nothing fancy, or you can just plug it into Wolfram Alpha. Okay, so I hope that helps.